Okay, the second example here, you got this picture here, triangle JKL. You got all these segments drawn inside of those, inside of that triangle. What type of segments are JN, LM, and PK? If we had to define what they were, what would they be? Very good medians. P is a midpoint because JL gets cut in half. M is a midpoint because JK gets cut in half. N is a midpoint because LK gets cut in half. So each of these go from a vertex to a midpoint, so each of these is a median. The point where they intersect, again, is called the centroid. Okay, that's not exactly what we're doing with this problem. There's a theorem in your book, Theorem 5.7. You should transfer that onto your paper at some point today. It states that the medians of a triangle are concurrent, and anytime they say lines are concurrent, it just means all the lines intersect at the same point. It's concurrent at a point that is 2/3 the distance from each vertex to the midpoint. All right, so the distance from the vertex to the midpoint, all right, they're saying that this number is 2/3 of that distance. All right, so if I said that JM was the whole distance, right? So 18 is 2/3 of JN. That's what that theorem's telling us. This point is 2/3 of the distance from the vertex to the midpoint. So again, JN is the entire distance, 18 is 2/3 of that. Which means that Q1 will be 1/3 of it, right? So if I just took that statement based on that theorem and those words, and I made it into an equation, 18 equals 2/3 times JN. To solve 18 equals 2/3 times JN, I want the 2/3 to go away, so I'm going to multiply by 3/2. Because anytime you have a fraction in front of a variable, you multiply by the reciprocal. So 2 and 2 cancel, 3 and 3 cancel, and we're left with JN all by itself equals, and then here 18 over 1, we can reduce first. 2 goes in 18 9 times, 3 times 9 is 27. So JN is 27. Here's a second way that you might like even better. JQ is 2/3 of the way, QN is 1/3 of the way. How do 2/3 and 1/3 relate?
Same denominator.
Same denominator, how else? What do you multiply by 1/3 to get 2/3? 1/3 times what equals 2/3?
2 over 1.
2 over 1 or just 2, right? So, if this is 2/3 and this is 1/3, this is twice as big as that. So if that's 18, this is 9. 18 plus 9 is 27. If you know like how long this little shorter piece is, so again, L to Q is the long piece, Q to M is the short piece. If you knew this was 8, 8 times 2, this would be 16. Okay, it's the same relationship that's happening over here. Instead of finding the whole thing, we're just finding this little piece, but then we just add to find the overall length. That's legal also, as long as you understand it. Again, this is directly word for word from the theorem. Creates a nice little equation you solve. But you can also, if you understand the theorem, that this is 2/3, that's 1/3, that's twice as big, that's half as big as that. So whatever that is divided by 2 makes that. The short piece times 2 makes that. Add up the short and long, get the entire piece. So take your pick on how you want to handle that. But again, medians have that property. That's how you handle that.